All right, let's talk about solving linear equations that have fractions in them. First thing I want to address is this statement right here, y fourths. It's important that when you see that, knowing that that is the exact same thing as 1/4 y. Whether the y is in the numerator or on the side really doesn't matter at all, but those are exactly the same thing. You'll see equations, some written like this on the left-hand side and some right on the right-hand side. The point is you attack those problems the exact same way. I'm going to show you two methods that are actually exactly the same, but just kind of different ways of looking at solving this kind of equation. They both require that you first understand how to find the least common denominator. So the first job we have is to find the least common denominator of 4, 5, and 7, our denominators in this case. The common denominator for those three would be 140. And in this fact, because our numbers are all what we call relatively prime, 140 just comes from multiplying 4 times 5 times 7. Alright, the first method for solving these types of equations is to write them all with the same common denominator. That's the first step. So my common denominator of 140, I need to multiply this first fraction on the top and bottom by 35. The second fraction I need to multiply by 28. And this third fraction on top and bottom I need to multiply by 20. And simplifying this, what I get is 35y over 140 plus 28y over 140 equals 180 over 140. Alright, so the next step in this method is, hey, once you have each term of your equation written with the same denominator, you actually can rewrite this equation without the denominator. So in this case, this equation becomes 35y plus 28y equals 180. This move works no matter what your denominator is that once you have the same denominator in each of the terms, then you can get rid of the denominators and just write the numerators in their own equation. The solution to this equation right here will be the same as the solution that had the equation with the denominators. To solve this equation, we combine our like terms on the left-hand side. 35 plus 28 gives us 63y's equals 180. And then we're going to divide both sides by 63. So we get y equals, we reduce 180 over 63, and when I reduce that, I get 27ths, which should be the solution to our original equation. Alright, let's talk about the second method, again, which is equivalent to what we just did, but it looks a little bit different. Alright, the second method for solving this, again, very similar to the first, exactly the same mathematically, but looks a little bit different. What I'm going to do is multiply each term by my least common denominator, which is 140. So I'll multiply this first term by 140 over 1. And I'm writing it as a fraction because this term is a fraction. The same thing here, 140 over 1. And then this last term on the other side of the equation, 140 over 1. I do some cross canceling here as I'm doing my multiplication. Then I simplify these terms. This first term, I'll get 35 times y in the numerator and a 1 in the denominator. Since there's just a 1 in the denominator now, what I can just write this as is 35y. The second term is the same, exact same, but becomes 28y. And the last term, 9 times 20 and over 1, which would be 180. And this obviously gets solved exactly the same way as the other equation, giving me the same solution of 20 over 7. So big picture, these methods are exactly the same, but some students like one way or the other, or your instructor might decide that only one way of these two ways is the way to go about it. And again, they're in general the same. They give you the same answer. They give you this same equation without the fractions, which is the goal of declaring fractions, and they also, of course, because of that, give you the same solution in the end.